This is a geometry problem, so we have to draw the diagram. We have a coordinate grid right here, and it says that the line y is equal to 1/3 x plus 1 divides the square region defined by that. So we have 1 right here, 2 right here, 0 or the origin. We have 1 and 2 on the y-axis as well. And this is the square region that the problem is talking about. And it says that the line, this line, we can draw this line, y is equal to 1/3 x plus 1. So when we draw that line, it kind of looks like this, where we have 1/3 up top right here, side length 2 right here, side length 1 right here, and we have 5/3 here, because if we plug in 2, we get 2/3 plus 1, which is 5/3. So it goes up to 5/3 for the y coordinate. We have 1 right here, and then a side length of 2 right here. Now it says that we have upper and lower region. That's correct. This is the upper, this is the lower. The line x equals a divides the lower region into 2 regions of equal area. So we have a line, let's just mark it as here. We don't know specifically where the line is yet, but the line is x equals a. And it divides the lower region, the bottom region, into 2 regions of equal area. So these 2 regions have equal area. And then we can just find the x equals a, the a value for this equation. Okay, so we can first find some pretty important things to solve the problem. And when I mean important, I mean the area of these respective regions. So this is a trapezoid, because this is a trapezoid. And we can find the area by adding the 2 bases and then dividing by 2 and then multiplying by the common height. So the area is 4/3. And we know that the total area of the entire square is 4. And we know that these 2 regions both have an area of x. They're both equal in area. So we can find the area of x. So 4 minus 4/3 is equal to 8/3. And then we divide by 2 because both of the areas are the same. So we know that we essentially split. Now we know that this square is split into 3 equal regions with an area of 4/3 each. Now this will help us find x equals a right now. So if we set the height of this trapezoid, as you see the bottom left trapezoid, as x, and then we know that the remaining height of the bottom right trapezoid is now 2 minus x, because the entire length is 2. And then we know that the height of this the other base of this trapezoid, the longer base, is 1/3 x plus 1, because we are essentially finding the y value for an x value of x, and we just plug it into this equation, and we have 1/3 x plus 1, because it is on the line. So we now know the remaining base for each of these trapezoids, and this will help us find what we're looking for. And we know that these 2 trapezoid areas are equal, but since we know the area of each one of these trapezoids, we really don't have to set them equal and find x. We can just find x by using the traditional method of finding the area of a trapezoid. So we add both of the bases, divide by 2 times the height, which is x, and that should equal 4/3. Now we have an equation to find x, which is what we're looking for. We multiply by 2, we have 8 thirds is equal to 1/3 x plus 2 times x. And then we multiply by, we can just expand first. So we have this equal 8 thirds. And then we can multiply by 3 on all sides. So we have this equation. And this is set equal to 0. We use the quadratic formula. Hopefully I didn't calculate anything wrong. Divided by 2. And then we have 2 root 17 plus minus -6 divided by 2. And we divide by 2 out. Obviously, -3 minus square root of 17 doesn't work. So we have square root of 17, square root of 17 minus 3. And that should be in the form that is needed because it's x equals a. So this is the x value that we want. Okay, that's also on the line and also satisfies all the conditions for x. So we know that x is equal to square root 17 minus 3, and then it's in this exact form. S is equal to 17, t is equal to 3, so the answer, the sum of both of these numbers is 20. The answer is C. Now we're going to move on to problem 7. It reads, Francis stands 15 meters directly south of a locked gate in a fence that runs east to west. Immediately behind the fence is a box of chocolates located X meters east of the locked gate. An unlocked gate lies 9 meters east of the box, and another unlocked gate lies 8 meters west of the locked gate. Francis can reach the box by walking toward an unlocked gate, passing through it, and walking towards the box. It happens that the total distance Francis would travel would be the same via either unlocked gate. What is the value of x? This is a geometry problem again, and we just have to draw a diagram. So Francis stands 15 meters directly south of a locked gate. So we have a locked gate right here. Francis stands 15 meter. Francis stands right here, 15 meters south. Okay. It also says immediately behind the fence is a box of chocolates. So behind this fence that runs east to west, there's a box of chocolates, and it is located east, X meters east of the lock gate. So let's just set this as X. The box of chocolates is right here. Now it reads, an unlocked gate lies 9 meters east of the box. So 9 meters east of the box is over here. An unlocked gate is right here. And then another unlocked gate lies 8 meters west, this direction. West is this direction of the lock gate. So there's an unlocked gate 8 meters west of the lock gate. Francis can reach the box by walking toward an unlocked gate. So this is the route that Francis can take, and then Francis can go walk all the way from the unlocked gate to the lock gate to the box. And then if he wanted to go this side, this route, he can go from the unlock gate and then directly to the box. And then he said the total distance Francis would travel for both routes would be equal. So we know that 8, 15, 17 is a Pythagorean triple. So we automatically know that the unlock gate to the fence is 17 on the left side. And we also know that we don't know anything further from this, but we can already solve for x. And the reason why is because if Francis went the left route, Francis would travel 17 plus 8 plus x. And then if Francis went to the right route, Francis would have to travel from Francis's starting position to the unlock gate, which is the square, because this is a right triangle. Square root 225 plus x plus 9 squared. and then he would have to travel an additional 9 to reach the box of chocolates. So we just set these two equations as equal, and we have 16 plus x is equal to the square root of 225 plus x plus 9 squared. We square both sides. X squared plus 32x plus 256 equals 225 plus x squared plus 18x plus 81. And then we solve. 14x is equal to 50. X is equal to 25 over 7. And we don't have to do any additional solving because we set x as the distance from the locked gate to the box of chocolates, as stated in the question. 25 over 7 as a mixed fraction is 3 4/7. The answer is C. Now we're going to move on to problem 8. It reads, Emmy says to Max, I ordered 36 Mac Club sweatshirts today. Max says, how much did each shirt cost? Emmy responds, I'll give you a hint. The total cost was ABB point BA, where A and B are digits and A is not equal to 0. After a pause, Max says, that was a good price. What is A plus B? So this is a simple divisibility problem in which the cost is AB. The cost is AB, B point BA. There's 36 t-shirts in total, so that means this total cost has to be divisible by 36, which means that this number has to be divisible by 9 and 4. So in order for this number to be divisible by 9, the sum of the digits has to be divisible by 9. So 3b plus 2a has to be divisible by 9. Now, in order for this number to be divisible by 4, the last two digits have to be a multiple of 4, or divisible by 4. And we can do, during the test, you can do casework. I'm pretty sure casework would work because we can go down the cases pretty quickly. So we can go down the cases 0, 4 because the last two digits have to be a multiple of 4. So 0, 4, 0, 8. It can't be 0, 0 because A cannot be 0. We have 112 or 12, 16, 20, 24. And you can go down the line until 1 has to work. I'm pretty sure it's midway, and the answer, the one that works, is 56, I believe. So B is equal to 5. Let's just double check it. B is equal to 5. And that means the sum is 15 plus A is equal to 6, which means that the sum is 12. So the total sum is 27, which is divisible by 9. 56 is divisible by 4. So the sum of A and B is 11.